Have you ever just looked around and wondered what connects everything? You, the air you're breathing, the distant stars in the sky. It sounds like this massive philosophical question, but the answer is actually pretty simple. So for the next few minutes, we're going to build a kind of chemist's framework for understanding all the stuff that makes up our entire universe.
I mean, think about it. Why do stars shine? How does a tiny battery power your phone? These questions seem worlds apart, right? One is about the sheer vastness of space, the other is something you hold in your hand. But what's really cool is that chemistry shows us they're connected at a super fundamental level, and it all boils down to one single core idea.
Matter. Yep, that's it. It's the one concept that links the heart of a star to the electricity in a battery. If you can really get a handle on what matter is and how it behaves, you're taking the first step to unlocking the secrets of pretty much everything.
So here's our game plan. First, we're going to nail down what matter actually is. Then, we'll explore the 4 different states it can be in. And finally, we'll zoom in and see how chemists sort all this stuff into 2 main buckets: pure substances and mixtures.
All right, first things first, let's get a crystal clear definition of what a chemist means when they say the word matter.
The definition is actually beautifully simple. For something to be matter, it just has to pass a quick 2-part test. 1, does it take up space? And 2, does it have mass? If you can answer yes to both, congratulations, it's matter. So that means you, the device you're watching this on, even the invisible air you're breathing right now, it's all matter.
Okay, so pretty much everything is matter. But, a rock is obviously very different from the air. And that brings us to our next level of understanding, the different states or forms that matter can take.
Let's start with something we all know: water. We see an iceberg, solid water, floating in the ocean, liquid water. To our eyes, they're obviously different. But to understand why they're different, we have to shrink ourselves down and look at what the individual molecules are doing.
And it all comes down to how the molecules are arranged and how much they can move. In a solid, like that ice, the water molecules are locked into a neat, rigid pattern. They're vibrating, sure, but they can't go anywhere. But in a liquid, those same molecules are still packed in tightly, but now they have enough freedom to slip and slide past each other. And that's literally what allows water to flow.
Now, what about a gas, like steam? Well, in this state, the molecules have totally broken free from each other. They're flying around like crazy, with tons of empty space between them. This is why a gas doesn't just take the shape of its container, it expands to fill every single nook and cranny.
So we've got solid, liquid, and gas. Those are the 3 states we run into all the time in our daily lives. But you know what? The universe has a 4th state of matter up its sleeve, and this one is way more energetic.
And that 4th state is plasma. The easiest way to think about it is as a superheated, super-energized gas. There's so much energy that the atoms themselves get torn apart into charged particles. Now, this might sound pretty exotic, but get this. Plasma is actually the most common state of matter in the entire universe. It's the stuff that powers every single star.
Okay, so we've covered the different states of matter. Now let's switch gears a bit and look at its composition, what it's actually made of. We'll start with the simplest category, which chemists call pure substances.
Now, the key word here is constant. A pure substance has a fixed chemical recipe that is exactly the same all the way through. A single drop of pure water has the exact same chemical makeup as a whole swimming pool of pure water. It's consistent.
And these pure substances come in 2 main flavors. First up, we have elements. These are the ultimate building blocks of the universe because they're made of only one type of atom. Then we have compounds. This is what you get when atoms from 2 or more different elements join together chemically.
And this is a perfect way to see the difference. On the left, we've got the element oxygen. See how it's made of 2 atoms? But they're the same kind of atom. Now look at the right. That's the compound water. It's made of 2 different kinds of atoms, hydrogen and oxygen, that have been chemically bonded to make something totally new.
So, pure substances are the fundamental building blocks. But honestly, most of the things we interact with every day aren't pure at all. They're actually a jumble of different substances all mixed together. And that brings us to our last category, mixtures. Now, here's the crucial difference between a mixture and a compound. In a mixture, there's no chemical bonding going on. The substances are just physically hanging out together, and each one keeps its own identity. It's kind of like people in a crowd. They're all in the same place, but they haven't joined together to become one single new thing. And just like pure substances, mixtures come in 2 types, We have homogeneous mixtures, where everything is so well mixed that it looks the same everywhere. You can't see the individual parts, like when salt dissolves in water. On the flip side, we have heterogeneous mixtures, where the composition is uneven. You can often see the different components, like the oil and vinegar in salad dressing.
And these things are absolutely everywhere. The air you're breathing right now, that's a homogeneous mixture of different gases. The concrete sidewalk outside, a classic heterogeneous mixture. Seriously, once you start looking for them, you realize our world is almost entirely built out of mixtures.
And that really brings us full circle. This whole system, states, substances, and mixtures, it's like the toolbox that chemists use to make sense of the universe. It's how we start to figure out what all this stuff is, so we can then understand all the incredible ways it can change.
So if there's one big idea to walk away with, it's this. The superhot plasma inside a star and the cool air filling your lungs are at their core made of the same kind of stuff. It's all just matter, arranged in different ways and playing by the same set of universal rules.
And that's really the point. You now have this new lens, a chemist lens, to see the world. So next time you're drinking your morning coffee or looking at a cloud in the sky, ask yourself, is it a solid, liquid, or gas? A pure substance or a mixture? This framework isn't just for a lab, it's for making sense of everything.